Alright, so what we're going to do is we're going to do some basic warm-up stuff and then we'll get right into it. Let's find the area of these rectangles. Now, to find the area of a rectangle, area is equal to L times W. Basically, you have a rectangle, one side is L, one side is W. It's the length times the width. So I'm going to multiply these two together. The area of this thing, 4 feet plus or times 3 feet, that's 12 feet squared. Make sure I put in the units there. This is 16 meters squared. Alright, this one right here is 2 times x. Now, we left it as x because maybe we don't know the length of the side, but when we find out the length of the side, I can tell you what the area is. Okay, well that's simply 2x, because the number 2 times the number x, and then I'll put it in units there, centimeters squared. This over here is x times x, so that would be x times x, which is x squared. And the units for that would be inches squared. Over here, I've got 2x times 3x, so that would be 6x squared. Because the 2 times the 3 is 6, and the x times x is x squared. And then my units for that would be millimeters squared. Alright, and then over here I have 10x meters squared. Now, keep in mind that these units at the end, they're not variables or anything. I'm just tacking them on. Don't read this as 10x times m to the second power. This basically means I've got meters squared, that's the units I'm dealing with, but the number that I'm dealing with, or the term that I'm dealing with, is 10x. Let's do this one up here. Alright. Now, I told you I wasn't a big fan of those tiles, and to be honest with you, I still am not. However, I see the value in them when we get to here. So why don't I start you guys off with these tiles, and then we're going to talk about this thing called the distributive property, and then what we're going to do is see if we can kind of wean ourselves off of these tiles. What these tiles kind of represent is the way they want you to start thinking about them is really for those of you who are visual learners, is they give you these tiles and they say something like you have an X tile that is this, that looks like this. You also have a vertical X tile that looks like this. And then this 3 right here represents 3 ones. So you got a 1 tile right here, and a 1 tile, and a 1 tile. So you make them inside of this little table or chart or whatever. Now if I were to multiply this thing out, it would basically be this guy goes with that guy, and that would give me this big fatty tile like this. And then this guy right here would kind of come down and look like that. This one would kind of come down and look like that, and that would kind of come down and look like that. So what is the area of this thing? That's, I guess, that's why we did the warm-up. So the area of this thing right here is x times x, so that's x squared. The area of this one is, the height is x, the width is 1, so it's x times 1, which is just x. This is x, and this is x. So if I wanted to figure out, well, what are the two things I have? Well, I've got x squared, and I've got 3 x's. See, here's my x squared, here's my 3 x's. So this thing is the same as x squared and 3x. Is this a quadratic function? Yes, it is. Now, one way I actually like to think about this, and I think that I've even taught you this once before, is we're using this thing called the distributive property. Basically, this x right here wants to be meet everyone inside of the parentheses. So I multiply the x times x and I get x squared. I multiply the 3 times the x and I get 3x. That would be the easier way of doing it without using these tiles, and I'm just kind of giving you the way of doing it with the tiles and then the way of doing it without the tiles. Let's try this one. This one's a little bit tougher. Let's bust out those tiles and see what we got. Okay, so over here I'm going to represent x plus 1. So I have x, and I have a 1. Now, of course, we'll give you these little pretty tiles to cut out, and you can go ahead and do that. But over here I have an x, and I'll have 2, so I need 2 little squares, which represents by 1 and 1. If I were to multiply out the whole thing, and get this little kind of thing going on here, like that. So this would be x squared. The area of that would be x squared. The area of this would be x. See, it's x tall and it's 1 wide. This is also x. The area of this thing is x actually because it's 1 tall but x wide. And then the area of this thing would be, well, what's 1 times 1? This is the same as 1 and 1. So I think that the thing that they want you to put inside of the tiles here is this part. Oops, that doesn't, you can't even see that. This part goes right here. So this is x squared. And then this part goes right here. So it's 2x, sorry. And then this part over here goes right here. So that would be just x. And this part over here goes over here. So it's 2. So my answer is x squared 2x x plus 2. Since I'm adding them all up together because I want the area of this whole thing. And so that would be x squared plus 3x plus 2. Because I'm going to add the 2x plus x because those are the same. The areas of that is the same. Those are the like terms. Cool? Alright, cool.